Please be seated. Good afternoon. Welcome to the Vrije Universiteit Amsterdam. Special welcome to the family of our candidate who is joining on YouTube. I open this public meeting of the College of Deans of the Vrije Universiteit Amsterdam for a PhD ceremony of the Faculty of Medicine by affirming that from our Christian origins to the present day, we practice science with a sense of wonder and inspired by fundamental values. Prior to the examination, I invite the candidate to give a brief overview of the research on which this thesis is based. The floor is yours.
Rector, on your authority and as authorized? After, yes. Good afternoon, everyone. Dear Rector, dear audience, I would like to walk you through the findings of my PhD journey, but first let me start with a background. Every 3 seconds, someone gets diagnosed with dementia across the globe. And today, we have more than 55 million living with dementia. And the numbers are not slowing down because they are projected to increase. Here in the Netherlands, we have around 300,000 people living with dementia. And across all the cases among the globe, 70% of them have Alzheimer's disease, which makes it the most common form of dementia and also the focus of my thesis. Inside the brain, Alzheimer's leaves several marks. So the brain starts to shrink and also loses its connections. And this massively changes the persons, their lives, and also their memories. So yes, Alzheimer's leaves its marks inside the brain, but what are those biology marks? If we zoom in, it starts with the accumulation of a protein called amyloid outside of the brain cells, followed by another protein called tau inside the brain cells. But they don't act alone, because there's also loss of synapses or loss of brain connections, neuron inflammation, and neuron damage. But now comes the question, how do we diagnose Alzheimer's? Doctors rely heavily on very powerful tools, imaging tools, such as the PET scanners particularly, in order to inform us where some of these harmful proteins are building up in certain regions of the brain, like the amyloid and tau. Although they work really well, but the problem is we can't take these PET scanners to the GP because they are huge, they are expensive, and needs to be placed in large hospitals. So we need an alternative which is more accessible and more scalable. And such alternative could be measuring the same biological markers in body fluids or measuring fluid biomarkers in CSF or cerebrospinal fluid and also in blood. And also before the beginning of my PhD, we had several of these tests measuring amyloid and tau in CSF that were up and running, but we needed more novel biomarkers. And also the question remained, can we measure the same biological markers or biomarkers in blood with high accuracy and good sensitivity? And there exactly comes my thesis, where it was set out to bring more affordable and accessible tests for Alzheimer's from the lab to real-world use. And in order to take these tests to real-world applications, they have to go through simple path, starting from the discovery of the biomarker target biomarker. And then we build a test in order to measure these biomarkers in CSF or blood. And then we make sure it works well through a technical validation or analytical validation before we try it out into real patient samples or clinical studies. And throughout the thesis, each of my chapters actually tackles one of these steps and addresses challenges that are recognized in these steps, whether it was developing a new assay or validating existing ones, or adopting a platform in order to better use an existing biomarker. And now moving to the results. My journey started by the developing of a new assay for a novel biomarker called beta-synuclein, or I would like to name it beta-syn. Beta-synuclein is quite a promising biomarker because it reflects the loss of synapses or loss of brain connections, and we need it in order to complement the diagnosis of Alzheimer's using amyloid and tau. And in order to establish the value of this biomarker, I measured the levels in CSF using a manual platform or the manual ELISA, as you perfectly seen here in this picture. And when we applied it to clinical samples, we have seen that beta-synuclein levels were significantly elevated in patients with Alzheimer's compared to those healthy individuals, as represented by the difference or the distance between the two boxes of the clinical groups. And with this study, it was relevant in order to show the promising potential of such a biomarker for Alzheimer's disease. The second challenge that my thesis was set out to address was about finding the optimum test in order to measure tau in blood, because there were several tests made by several manufacturers on several platforms, and we didn't know which one to select. So to answer this question, we used one single platform called the semi-automated SIMOAM platform, and we followed the same analytical protocols in our lab. And what we found that some assays actually outperformed or performed better than the others. As we can see, for example, with assay number 1 or test number 1, the magnitude of difference between the clinical groups was much larger compared to the other assay, even using the same set of samples. With this study, it was relevant in order to better understand the performance of such tools and guide us about the selection when we need to select a tau test in blood. And the third challenge that my thesis addressed was about finding the optimum cutoff or threshold for amyloid and tau in blood. Because the problem actually lies here in this figure, as you can see. You can see the blue curve representing Alzheimer's group and the green curve representing the healthy individuals. But now comes the question, where do we draw the line that it says this is probably Alzheimer's diagnosis or not? So in order to do so, we used a fully automated platform which is placed in large hospitals, or named the Lumipulse. And this platform enabled us to generate high precision data for a large set of samples, not only in one location, but we did so here in Amsterdam and in Perugia in Italy. And with this study, we were able actually to validate the performance of such fully automated assays and their value in blood, but we also generated preliminary cutoffs for tau in blood, as well as for amyloid in blood. And such study was relevant in order to better guide us and the field when we say where should we use the cutoff, or which cutoff point should be used. And the last challenge in my thesis was about making these tests closer to patients and make sure they are used here in developing countries as well as in developed countries. So to do so, I targeted a protein called neurofilament light, or the NFL, that reflects the brain degeneration. So instead of the large instruments you have seen across the presentation, here we used a portable lateral flow test, as we probably know it from the COVID-19 testing. But this is much more advanced because we could quantify neurobiomarker with a portable reader. The benefit we're bringing here is that with this approach, we needed no electricity because the reader system uses battery, and it's much more affordable, which altogether can make sure that we bring these tests closer to patients wherever they are. And to end, I would like to reflect back on the cover of my thesis with the main message, which is about biomarkers only matter if they reach the hands of real patients, whether this is done in large hospitals or small clinics. Thank you.
Thank you very much. Perhaps a glass of water necessary?
Yes.
Sip of water. Excellent. I would now like to hear whether the candidate is prepared to defend the thesis.
Director, on the authority and as authorized by the College of Deans and according to the decision of Dean of the Faculty of Medicine, I am prepared to defend my thesis entitled Bridging Gaps in Biomarkers Use for Neurological Diseases from Assay Development toward Clinical Implementation, in order to obtain the degree of Doctor of Philosophy.
Thank you. I give the floor now to Professor Pijnenburg. She is Professor of Dementia at a young age at this university. Professor Pijnenburg.
Thank you. On the authority of the rector and by virtue of my right, I would like to discuss with you about your thesis. And first of all, I would like to compliment you with a very beautiful thesis. I think you outlined very well what the goals of your journey were. And you also very nicely depicted it on the front page of your thesis. I know you are not a clinician, but when we talk about implementation, of course, clinicians can ask questions that are related a little bit more to implementation. And my questions relate to chapters 2 and 3. And my first question is actually about chapter 2, where you develop a CSF test, actually multiple tests for beta-synuclein, which is considered a synaptic marker for Alzheimer's disease. It has already been found by others, and it has been found specific for the disorder Alzheimer's disease, and it has potential for early diagnosis. Always when it comes to biomarker development in Alzheimer's disease, I'm a bit critical because we can already diagnose Alzheimer's disease with biomarkers. It has already been taken into account in the criteria to diagnose Alzheimer's disease with the ATN classification. And you give a rationale for looking for this beta-synuclein as a potential other alternative biomarker for Alzheimer's disease because the core biomarkers, the core fluid AD markers, of which I think you mean amyloid beta and tau, change with AD-related pathophysiological changes over time. That is what you're saying in the background of your paper. And you're giving this as a rationale for the study to beta-synuclein. And then you have multiple ELISAs, but one which interacts with the medium part of the molecule gives also the impression that there is a difference over the stages of Alzheimer's disease. You can also see it in the box plots. So it's not that increased yet in the early stages, but more in the later stages. And I was wondering, because you mentioned this is kind of potential of this marker to identify different stages of Alzheimer's disease, if you think it outperforms the core biomarkers in this respect.
Learned opponent. Thank you so much for your words and your compliments. Indeed, you're raising a very valid point about the potential of beta-synuclein as an early biomarker for Alzheimer's disease. And I do agree with you that the core biomarkers are doing already a great job in defining the neuropathological changes of Alzheimer's disease. But here we see the use of, or I see the use of beta-synuclein as a complementary in order to reflect synaptic degeneration in Alzheimer's disease and not as a replacement for the core biomarkers. And it actually was already elevated at the SCD levels, so at preclinical stages. So, yeah.
But I assume that you have selected your patients. If a person has subjective memory complaints, so there's no dementia yet, no even objectifiable cognitive decline, you must have selected these patients based on the core biomarkers. Otherwise, you could not say that that patient has underlying Alzheimer's disease. So how can you then be so sure that it's complementary?
I wouldn't say particularly the focus here should be on the diagnostic potential of beta-synuclein per se, but should be on the more future use and other contexts of use, such as the clinical trials or also prognostic use and also biological staging, rather than diagnostic standpoints.
So then the staging is important, and you can already find it increased in the early stages.
Indeed.
Yeah, but then still, I wonder if you can make a diagnosis based on A beta and tau, which apparently, according to your introduction, change over time. Why wouldn't that be enough?
You're raising a good point, actually, because Alzheimer's is not A beta and p tau alone. And I believe that we would need to complement it until we fully capture everyone on this planet, like who have Alzheimer's, we would need novel biomarkers in order to fully capture the heterogeneity of the disease. So in that sense, I think there is a room for synaptic biomarkers in general, and also beta-synuclein particularly, to be added to the in the future as non-specific biomarkers like the GFAP and NFL in order to complement what we know better about Alzheimer's. But
I think I would be convinced if you could, for example, show that in the subjective memory decline group, tau was not yet increased. But do we know these data from the people that are in your study? I can imagine that maybe in the beginning, when you have subjective memory complaints, it's just amyloid changes and then later tau.
Yes.
But these patients have been diagnosed with subjective memory decline based on AD. Did they have not increased tau levels? Are you aware of those levels?
No, I wouldn't say so, because the increased or biological confirmation in CSF biomarkers was a criteria in order to select these patients and also cluster them into our cohort during our cohort selection. So in that sense, the study design wouldn't be answering this question, whether beta-synuclein rises before tau or not, as from the temporal point. Yeah.
So, but I still a little bit in doubt why you think this beta-synuclein has an additional value over A-beta and tau. It is shining a new light on the disease, that's true. It's showing a different mechanism, but wouldn't tau also be a measure of synapses getting lost, or do you think it's not a synaptic marker?
It's not a synaptic marker, and actually knowing that around 16% from the latest review, or the 16% of the new clinical pipelines are targeting synaptic degeneration. So therefore, we need a specific marker for synaptic degeneration in Alzheimer's disease.
Yeah, so I think you convinced me. Thank you. And now I do have room for another question, I hope. Rector?
Yeah.
So the next question, so maybe one question before I go to chapter 3 is, do you think it would make sense to include in your study patients with autopsy-confirmed Alzheimer's disease instead of biomarker-confirmed Alzheimer's disease? Would that make a difference for your experiments, or do you think relating the findings to the core biomarkers is sufficient?
I think where we're standing nowadays, I would think biological definition of Alzheimer's based on CSF biomarkers is more than enough at the moment.
Okay.
Yeah, but if we were talking about this 5 years ago, we would definitely needed more autopsy to confirm.
Okay. So when we go to chapter 3, where you have developed lateral flow measurements of neurofilaments, that's something that you can use in the house that you can see here on the front page, not in the big hospital, so in the point of care. And you are very optimistic about it. So I thought, well, I have to read it a little bit more detailed. And then I found that when you look at the correlations with the existing neurofilament measurements, for example, by Simoa, which is highly sensitive, it does not correlate so very well. But you're showing that you can detect it with those methods. So that's the first step. And then you also describing in your discussion that, yes, of course, there's some more validation and more analytical upgrading necessary. So I'm just wondering, do you then really think this is going to happen and you will have an ideal lateral flow biomarker neurofilaments? What are the odds that this is really going to work? What is your impression?
Yeah, this is a very sharp observation, and I would like to start from the end of my answer. That yes, I do. If I'm allowed to say, I believe that it's one day we can use point of care tools in different settings depending on the context of use we select. But if now to elaborate. The poor correlation here, especially with the Simoa, I speculated it could come from the difference in the antibodies, although we've seen that Simoa correlates quite well with Lumipulse. But since this is a novel platform, we're still learning and finding our path in it. And I clearly acknowledge that there is some work needed to be done. But the idea was not to prove that it's ready and for tomorrow's use, but to start to tackle these challenges, that how can we find our path forward in order to bring such tool and close the gap in between healthcare systems.
Yeah.
So the point was to just start and to prove that we can detect these values, knowing that the turnaround time here was around 15 minutes readout.
Oh yeah.
Yeah.
But that's really good. And how long have you been working on this project to achieve this result?
I mean, with this technology, it's like sort of my passion. I've been working on it for a while already, but here we've managed to work on it for 2.5 years, but with focus on 1 year, around 1 year, sorry. Yeah.
Very
plenty of work, and my colleagues are working on it.
Well, short question. Yeah.
Do you think you were making a plea for using it in children neurology? Would you also include adult neurology in this plea?
I would say both.
Yeah.
It depends on the question we're asking or the context of use and where we are in the developing or a developed country.
Yeah. Well, thank you.
Thank you.
I'll return the word to director.
Thank you very much. The next opponent is joining us online. It's Dr. Hauptgebauer. He is junior group leader in the working group of translational biomarker development in the Department of Neurology at the Ulm University in Ulm in Germany. Dr. Hauptgebauer, the floor is yours.
Thank you very much. On the authority of director and by the virtue of my right, I'd like to ask you some questions regarding your thesis. But first of all, can you hear me, everyone?
Yeah.
Okay, great.
We can see you also now. Yeah.
Right. I really also like to congratulate you on your thesis, which really shows, I think, also the story of your PhD program from kind of the discovery, technical validation, the journey into the implementation in the clinic. I really, really love that. And I also see all the work you've done with the development, which I know is a lot of actual work in the lab and kind of also detective work to continue and to improve those assays. So that is really great. My first question goes also into the direction of the previous opponent regarding your work on beta-synuclein. You nicely explained already a bit that in the framework of the ATNs and how this could help also in addition. I would like to ask you a bit about what you know also about beta-synuclein, how specific it is really for the CNS, and in that regard, what you believe in. You also showed us, all right, I think in the outlook of this chapter regarding the use in blood, if you can measure it in the future using blood assays. And in that regard also, what you think could be maybe additional benefits of your C-terminal or mid-terminal assays compared to the already published N-terminal assay.
Learned opponent, thank you so much for your words, and I'm really happy to see you again after the MIRIADE meeting, so I've done in a while. You're asking first about the potential use of the specificity of beta-synuclein in CNS. Indeed, we have seen that, or it's known that beta-synuclein is quite specific to CNS, or in other words, it's not peripherally known to be released. So that gives it more specificity towards the CNS and being representing synaptic degeneration in the central nervous system in Alzheimer's disease. So, and your second question, if I remember correctly, was about the move to or transition towards blood. If I
exactly, yeah.
Yeah, already we started in ADX. We have been working on developing a blood test a while ago, but to the best of my knowledge, it's already up and running and showing good performance with in order to differentiate or stage the disease of Alzheimer's, starting already to change at early stages from SCD, going up with the progression of the disease. And yeah, and also not also in our hands, but knowing that you are one of the early inventors of beta-synuclein, it is already shown to be working not in CMOA, not in immunoassays, but also in the mass spec in your hands, and also in the IP MS assays as well. So in blood, beta-synuclein is also showing a very good performance.
Okay,
Perhaps I
thank
missed
you.
your third question or your third
yeah.
point.
Yes, thank you. But also in that regard, now, what do you believe? For researchers and or neurologists, it's also really important to see that the correlation between the CSF levels and the blood levels are at least moderate, better to have them really good, as you often seen for the neurofilaments, for example. But what do you expect for beta-synuclein, or you have maybe data in mind how this could look for beta-synuclein?
I would say it is a very strong correlation. We have seen strong and significant correlation between the levels in CSF and blood. I would say compared to other synaptic biomarkers that did not show the same correlation between both levels in both compartments. So this is a really strong point for beta-synuclein and as a presynaptic biomarker compared to the other presynaptic biomarkers as well.
What do you think could be also the reason why some markers which don't really greatly correlate between the two compartments?
Perhaps we are referring to the if the protein is released from peripheral sources in response to other incidents or injuries, not only to the CNS. And then I would say the concentrations or the levels in bloodstream are more pronounced compared to the CNS, because it should go the other way around from CNS to blood usually.
Yes, exactly. So I think it's always really important to have a look at peripheral sources. Even also for p-tau, there might be sources in muscles, and why the field is working on blood-derived or brain-derived p-tau. And for beta-synuclein, there might be this advantage that it's kind of nearly exclusively expressed in the CNS. We didn't find really other sources yet, and that's why it could be really promising blood biomarker. So far, you may be aware also the published work on the Simoa beta-synuclein has a bit of limitations. You developed two new assays, the C and the mid-terminal assay, and then also for the mid-terminal assay, which has kind of lower levels. You're right; it might have some do with some proteolytic stuff. But so do you expect this might then work better in blood than the N-terminal assay, or what do you think about that?
Indeed, I'm convincing that we have seen already very good performance from the N-terminal assays in both CSF and blood, but on the clinical aspect. So if we go to the analytical aspects, comparing the three assays that target the three regions, whether the N or mid region or the C terminal, in that sense, I would say the analytical aspects are also quite crucial, and we have to consider consider the selection of one of the beta-synuclein specific assays. And in that sense, I would be more leaning towards the mid-region beta-synuclein assay, knowing that, but commenting on whether it works in blood or not, I have seen already preliminary internal data from the blood assay in our group and also in ADX, and it's showing very promising performance to reflecting the same pattern of increase in CSF.
Okay, thank you. I'm really looking forward to that data. Yeah. Okay, great. So I think I have some more time to move also to the next chapter. I was really impressed with your lateral flow assay, which I also really strongly believe could be future diagnostics. And as you write, this could be really important in point of care, and in point of care also acute conditions are often, of course, looked at. So I was wondering a bit if you know, so your knowledge about protein biomarkers like neurofilaments and others, for example, in acute conditions like traumatic brain injury, and you know their time course, their level changes and time course of those diseases, for example. Do you think maybe it would be also making sense to establish a point of care test using your lateral flow for other proteins, which could look different than NFL?
Indeed, I totally agree with you because this is very valid. And I would say immediate candidates in that case would be the GFAP, for example, to start with, tau in general. But I would maybe focus more on the GFAP use also for the TBI, because it was shown that it is increased within 8 hours already before the rise of NFL. And it's been used in the Abbott recently approved assay for the emergency assay by Abbott. So it was a combination panel between the GFAP, NFL, and another biomarker, S100 or something. I knew it to the top of my mind. So I would say maybe we could start with the GFAP in the soon future because the levels are within the limit of detection of such technology, knowing that we already can achieve down to 10 picogram per ml sensitivity, especially using the upconverting nanoparticles, which is I would say the magic tool here, that giving the edge to the lateral flow technology per se, and making it not looking as the conventional ones or the typically fluorescent lateral flow assays.
Okay, yes, I totally agree that the GFAP could be really interesting as it increases so early and fast. Could you kind of, from technical side, I mean, you're the specialist in the lateral flow, could you do also a two-plex assay kind of using this system and so you can measure both at the same time?
Yes, indeed.
Please make this answer short.
Yes.
Because of the time. Yeah.
Yes, we can actually on the same lateral flow strip or parallel 2 strips to each other. So it is perfectly possible.
Thank you.
Excellent. Thank you, Dr. Haukebauer. Our next opponent is Professor Algeciras Chimnich. She is Professor of Laboratory Medicine and Pathology at the Mayo Clinic in Washington, United States. Professor Algeciras, the floor is yours.
Thank you. On the authority of the rector and by virtue of my right, I would like to first congratulate you on your work and your presentation, and thank you for the opportunity to be part of your thesis committee and your defense. I would like to start by asking you some questions related to the beta-synuclein assay that you developed. And one of the rationales for developing both the mid and C-terminal assays was to increase the specificity as the N-terminal assays tend to cross-react with other synuclein families, especially alpha-synucleins. So I would like to understand a little bit better, how did you evaluate the cross-reactivity of the of alpha-synuclein in the mid and C-terminal assays that you developed?
Learned opponent, thank you so much for your words, and I'm really happy that the copies reached safely to the US before the time today. You're actually pinpointing to the analytical validation part during the development of our assays, and on that I would like to, we have done actually several aspects to make sure, because we made our antibodies from scratch, especially the capture antibodies, and we used a commercial detection antibody in the ELISAs. And we made sure that the novel antibodies are quite specific towards beta-synuclein in different schemes already while designing the antibody clones, and also in the lab in our hands. When we were selecting among different clones, we also ran, that was the part about developing the antibodies. When we had them up and running in the ELISAs, I made sure that I get them into the analytical validation known protocols, or from the consensus we have been using in the MIRIADE. It's a protocol we have been following. And to do that, we have already ran several comparisons while we coating, for example, alpha-synuclein as a captured to the surface of the ELISAs, and then we ran the alpha and beta binding antibodies, and we also ran our specific beta-synuclein antibodies, and we have seen almost negligible signals or background signals towards the alpha-synuclein when we used our antibodies. So that was an evidence to give us confidence in the specificity of the assays. But I would say it was not challenged in the cohort selected here. But analytically and in the lab, we do trust the specificity of the novel beta-synuclein assays.
So were you able to use samples or spike samples with recombinant alpha-synuclein and show that they didn't cross-react on these two assays? Is that, could you expand a little bit on that?
Yes, indeed. I did run a small experiment where I spiked CSF with red blood cells in order to see the expected rise of that alpha-synuclein is causing to the assay. This experiment wasn't conclusive, and I haven't seen that that impact I was expecting from the red blood cells on rising the background. But in other means, when I directly coated the proteins on the surface of the ELISAs and then ran the other way around. So there was no capture antibody, but the capture here was the beta-synuclein or the alpha-synuclein. And then I used the 3 antibodies. We're talking about the N-terminal antibody and both the other 2 antibodies, the mid-region and C-terminal targeting. And by then, we haven't seen any cross-reactivity towards alpha-synuclein with our assays, while we have seen the cross-reactivity happening with the alpha and beta targeting antibody, which is sort of expected, but we needed to have this lab proof in our hands.
Thank you. When I look at the performance specification of both of these two assays and think about, you know, what the ideal performance should be for when you're developing an immunoassay, one of the aspects that we evaluate is recovery. And I noticed that for both of your assays, the recovery was quite low. Ideally, we want to see a recovery of ideally 100%, but at least, you know, plus minus 10%, meaning 90 to 110%. In your particular assays, the recovery was only in the 60s, so 61 to 66% recovery, depending on the assay. Can you speculate? First of all, can you explain a little bit better what was used? How did you do these experiments? And can you speculate what is causing that low recovery?
Yes. So yeah, I totally agree with you. This is a very sharp observation about the recovery being or falling out from the accepted criteria between 80 to up to 120%. And we acknowledged that during the when we shared the data about the assays, that some work needs to be done in terms of optimizing the performance. The way we have done the recovery here is by basically spiking 3 different concentrations. I mean, high, medium, and low, based on each assay's calibration curve, sorry, and then we measure the recovery upon dilution of these samples. But none of them actually fully fell within the accepted criteria, and I would maybe speculate that due to that some work needs to be done on the assay diluent in order to dilute or mitigate the matrix effect that is maybe causing the recovery to fall out. But that's from the analytical side. But if we look on the clinical aspects, applying the same set of samples to the 3 assays, and particularly the novel assays, we have seen really good performance complying with the core biomarkers. So in that sense, I wouldn't say it affected, but I would like to see it as perfect performing as possible. So yes, there is definitely needed to be some optimization.
How can you explain or expand a little bit better, at least like what will be the next set of experiments that you will do for trying to optimize recovery? I know you mentioned, you know, trying different diluents, but what aspects of that diluent matrix will you consider to be key to try to optimize the recovery?
Honestly, it was a bit surprising to me because CSF to me is known to be a cleaner matrix compared to serum or plasma. So struggling with the recovery and CNS was a bit surprised to me compared to the other assays. But if I could think of something that needs to be done, I would definitely, as I mentioned, start with the assay diluent and then some tweaking maybe in the by speculating the antibodies, maybe some of the chemistry of having a full mAb monoclonal antibody with the FC part maybe is causing some binding to general proteins or some cause of the background. So maybe I would consider, if I have the facilities, I would consider a Fab2 or Fab fragment maybe on the ELISA, and also in a more ultra-sensitive platform or technology such as the Simoa, then maybe it's just arbitrary to the platform we have used, which is the manual ELISA, So I would think of at least these two for now.
Do you think anything related to the stability of the protein or is causing the low recovery or the structure of the protein?
It's already a very yeah. I've already thought about that part. That's I agree with you about raising this point, but we have tested freeze-thaw stability over time, and it was shown to be already stable up to on average for 3 rounds. So I wouldn't reckon on the freeze-thaw being or the stability of the structure of the protein being the driver, at least at this stage, but it could be definitely like a factor that affect in a way. Yeah, I totally agree.
All right, thank you. I'll move on to your NFL lateral flow assay, and I have a question about that technical question as well. So one of the challenges that you mentioned on the discussion and your results was the reproducibility of the two-step approach, possibly related to the aggregation of the reagents. So if you have to continue to work on this assay, can you tell me what improvements can you think be made to the assay to achieve better lot-to-lot consistency?
Again, could you please make a short answer?
Sure thing. To answer short, I would focus more on the protocol itself, because there maybe the pre-incubation is causing some difficulty in terms of the maintaining the less variability. So I would start with the protocol, reassessing it while balancing this, not losing a lot of the sensitivity achieved.
Thank you.
Okay.
Thank you.
Thank you very much, Professor Algeciras. The next opponent is Dr. Montolio Gaia. She is a researcher in the neurochemistry lab of the Department of Psychiatry and Neurochemistry of Gothenburg University in Sweden. Dr. Montolio, the floor is yours.
Thank you so much for the introduction, and on the authority of the rector and by virtue of my right, I would like to congratulate you for this fantastic thesis, going from like the development of the assays to then clinical validation and covering like anything that involves biomarker discovery and development. And thank you for inviting me to be part of this committee. And the other opponents have been focusing a lot on chapter 1 and 2, so I'm going to focus a bit more on 3 and 4. More on the p-tau assays and the A-beta in lumipulse. And I would like to start by asking if you could describe what are the differences and similarities maybe of the analytical platforms you've used in your thesis, because you've used a lot of immunoassays. We can say they are all immunoassay based, but you've used classic ELISA, Simoa, lateral flow, and also lumipulse. So can you quickly go through differences in these platforms?
Learned opponent, thank you so much for your words and your compliments, and for joining today. I would like to start from focusing on the manual ELISA platform, since it's a bit, we all know that it's a bit limited in sensitivity. Even the best ELISA would struggling to go down with in this range that we are already detecting with the other platforms that were included in this thesis. So knowing that most of the typical ELISAs are manual, I would say it is more for discovery stages, and also due to also their limited sensitivity. But if we more focused on the semi-automated platforms such as the Simoa or or I would like to call it the ultra-sensitive platform, or more the fully automated lumipulse, then we get higher in sensitivity, starting from the CLIA and going all the way to the Simoa, which is known to be a bit more sensitive. But on how both platforms work, both are beat-based actually, but there are some differences, and I would like to focus on the differences as an end user. Then, for me, the Simoa is the benefit here is that it is sensitive platform, but it's also an open platform, so we can do in-house development on it, while having the facility to have a high throughput, also clinical studies run on it. But if we more compare it to the lumipulse, it is a closed system, so there's no in-house development here. We work only with commercial kits, but the benefit of such assays that we can run also high throughput, but it's a more IVD level of precision and high throughput precision. So that's more comes towards the end stage of biomarker development. And this is how I would place them. And then parallel to them, to complement where we need, is I would put the lateral flow technology, but not in the same spectrum of development, but rather to complement these platforms whenever we need to use it for certain context of use.
Okay,
I hope
thank you
this
very
answers
much.
you.
Yes, it was a very good answer. But then if we move more into like the comparison of different assays, let's not focus so much on different platforms, but in chapter 4, so in the paper comparing the different p-tau assays, comparing p-tau 217, 181, and 231, you have a very nice ROC analysis looking at how these different assays can discriminate. Actually, people are looking at the thesis, so it's page 98 if people want to look. So you have all these different AUC ROC analysis, but we see a clear differences between different markers and different assays. So why do you think we see these differences? Is it due to the platform? Is it due to the marker? Because it's p-tau.
Yeah, this is a very valid question, and this is actually was the main question that we found this study upon in order to address this question, whether the differences in the performance of these biomarkers was biological or analytical. I would like to say both, actually, because if we start comparing one biomarker, or the similar biomarker, such as the p-tau 231 from Gutenberg and the ADX early version of p-tau 231, there was distinction in performance favoring the Gutenberg assay, and this was not biologically but rather analytical difference in the setup of the assay, whether we're talking about the detection antibody used or we're talking about the reagents used in the assay diluent. So this, if we reflect on the same biomarker, but when we go to the biological aspect, some biomarkers of the p-tau are known to be early in the process of change early in the neuropathological changes, such as the p-tau 217, followed by the p-tau 1, maybe 231, and then 181. So biologically, there is a difference, yes, in how they perform and how they could be used or implemented in the as biomarkers for Alzheimer's.
Mm. But
Yeah,
then,
so to sum up, I would say both, actually.
okay, both. But then if you think there are differences in these p-tau markers, and you just mentioned 217 might be earlier, but then you think the other markers might be more useful in other disease stages, or you think since 217 is the best here, it should always be the chosen marker for diagnosis?
For now, actually, most of the data, or because it started earlier, was generated on p-tau 181 in plasma. So it was a bit one step ahead from the p-tau 217. So I would say as long as we, and I maybe forget also the aspect of the platform used as well, because that also play a key role and on how we see the performance of a biomarker. So I would say that P217 is definitely a very promising biomarker, but we still need to do more analysis on the preceding ones, or the relatively newer ones, like the p-tau 231, in order to fully capture the temporal trajectory of the P231, whether it's earlier than 217 or comes slightly later on. But definitely the p-tau 181 comes later than the p-tau 217. From what I've seen in the literature.
Yeah, but something also to maybe discuss is, of course, the temporality is very relevant, but also the fold change in the marker is going to play a huge role in the technical stability of that marker. So we've seen that 217 is a marker that has higher fold changes between healthy and
yes.
AD patients. So of course, even not only because if it's an early marker, but even at other disease stages, these huge fold changes might make it a better marker because it's more technically reliable. But that was a very good question. I want to move on more into the next chapter and using the LumiPulse as an automated platform and how you use p-tau 181 and the A-beta ratio. And it's also discussed throughout the thesis. For example, in the beta-synuclein chapter, you also try to play with beta-synuclein versus A-beta ratios. So I would like to know your opinion about using ratios for with markers, and how do you think this can affect their clinical implementation, or can be the effect in their accuracy or not?
Yeah, indeed, the ratios here could solve a small issue when it comes to the difference in baseline levels, especially for the biomarkers. So some people do differ in their baseline for the amyloid beta 40. So having the ratio here was quite a good solution in order to make it more reliable as a biomarker. So here I wouldn't use the absolute or the absolute biomarker concentration, but rather the ratio. And when we also applied the same in the beta-synuclein, I've seen massive improvement in the performance, favoring the use of the ratio. So I would speculate that it does also do the same thing on the when using it or applying it in beta-synuclein, that it do count or correct for the differences in baseline and the individuals selected in those clinical studies.
But so for A beta 40, beta 40 and A beta 42, we know that there is an imbalance in Alzheimer's disease. And it's that like a change in the processing of APP and moving more to A beta 42. But what do you think about when using ratios of different proteins? Like, for example, now we know that FDA approval for a blood test using p-tau217 in A beta 42. So how do you see these ratios when using different proteins, not only A beta, which is kind of the same protein?
I would say it maybe is also correcting for a critical confounder for the changes in levels of these blood biomarkers, such as the kidney or liver dysfunction. So maybe, or also the different additional factors. So I would maybe start with the kidney function, that these relative ratios would correct or help us better understand the levels without misinterpreting the increase due to other confounding factors, such as the kidney or liver dysfunction.
Yeah, and I wanted also to ask you about that. So you also mentioned in the thesis about high p-tau levels when having chronic kidney dysfunction.
Could you phrase this question shortly, please,
Yeah.
and give a short answer as well?
Okay,
Yeah?
then I can phrase it very shortly. So then do you think that ratios would be the solution for these false positives in chronic kidney dysfunction?
No, I wouldn't say no. I would say no, not the only solution. Yeah.
Okay, thank you very much.
That's a short answer indeed. Thank you very much. The next opponent is Professor Wolf. She is Professor of Therapy of Leukodystrophy at the Department of Child Neurology at this university. Professor Wolf, the floor is yours.
Thank you. On the authority of the rector, by virtue of my right, I also would like to discuss your thesis with you. First of all, also my congratulations to you and your whole team. I really enjoyed reading the book and I learned quite a lot. So I'm a child neurologist, so I see children of all ages and with usually very rare diseases. So this is a bit different from the patient population my neighbor is seeing. So when we first started measuring neurofilament light levels in very young children, we were a little bit surprised by the normal range, which is relatively high in the first 1 to 2 years of life, and then gets low. And later on, it slowly starts to rise again. Do you have any explanation why the neurofilament light levels are so high in the young children?
Yeah. Learned opponent, thank you so much for your words, and I'm really happy to meet you in person. This is indeed a very critical point, because that's also what we have seen while establishing the reference ranges for the neurologically healthy children, that the levels were relatively higher before they start to decrease by the age of 9, and then they sort of go steady from the age of 9 until the age of 18. And I would maybe speculate on that due to neurons crowning, or like it's part of the development, and also and newborns, the within the body, the liver and kidney are not fully functioning by then, so that's also might be playing a role in increasing indirectly the levels due to impaired clearance or clearance of these biomarkers or the NFL from their blood. So altogether, I would say part of it is normal, part of it is abnormal, and that's what we have seen in some of these diseases, including the MLD and also the SMA, and there where we spotted the issue or the gap that we might be using NFL for such context of use.
But if I go back to the levels of NFL, certainly in the first 2 years, they are relatively high. So I don't think it's only the clearance explaining those high levels.
Let me check but in general, I would say what I meant is that it's not only the clearance or the incomplete liver and kidney function, but I would say it's part of the neuron development process that it's like the turnaround is also very high in order for these children to develop.
Yeah, I think it's one of the reasons. Probably there are more reasons. Like also, if you think of the head size of an infant relatively to the body weight, it's much higher. So that might be an explanation. And another explanation may perhaps be the incomplete myelination of the axons.
True.
Which could lead to a spillover of the neurofilament, which is higher than when you have a good isolation of your axons. Yeah, which brings me to my next question. We see that in many of the diseases where we work with leukodystrophies, the neurofilament levels are elevated, sometimes really high, like 1,000, which is very high. But we have the problem that some of these diseases also affect the peripheral nerves. I then don't know where the neurofilament light comes from. Is it coming from the brain or is it coming from the nerve? Are there any possibilities to distinguish between these two?
This is a very valid point, actually, because I would say the NFL is a fairly general biomarker, so it could be released from both peripheral sources and also central sources. But this is a good point. How do we make the distinction then? How do we make the distinction then? I would think about measuring it in the levels in blood and how do they reflect? How do the levels reflect in CSF, especially if we're talking about the CNS incident? Then we would start by comparing both levels and how do they correlate to each other. Then we'd have a better picture on the situation.
Okay. Because we don't want to do so many lumbar punctures in our children, any other kind of body fluid where we could perhaps measure a better representation of CNS biomarkers?
Especially for NFL, I would say, yes, I would say the blood could be a good alternative. If that's what you mean, or this is what you want me to go to blood?
I've heard something about tears, lacrimal fluid. Is this used at all for?
Yes, that was one of my early projects during the PhD where we worked on trying to extract NFL from tear fluids. It is extremely low, I have to say, very low abundant levels, but it is doable to measure the levels in tears. But I would say also very typically urine, which is more accessible. But I haven't worked on urine as a metrics during my work, but I only worked on the blood and tears fluid. So both would be very accessible, but I would more be leaning towards the blood or another maybe exploring the urine.
To be honest, I think blood is better too than tears is also difficult to get from a small child. Yeah,
totally agree.
So we because our diseases are so rare, our patients are also distributed often throughout Europe or even the world. Measuring some biomarkers in dried blood spots would also facilitate our work a lot. Is there any experience with this?
Yes, this is actually really promising pipeline work in our lab and also in our labs, including also the Gothenburg lab by Dr. Laya. We and them also, we are doing the same line of research about exploring the dry blood spots levels when we target NFL. Usually it does work, and there are a couple of studies out showing that it is beneficial, it is used as a metrics, but the issue comes with the magnitude of concentration. It is around 10 times less when we talk about the blood levels, but it's still detectable using ultra-sensitive technologies. So dry blood spots would be then sort of an interim solution from the point of care. So it does help to bring patients closer to where we are in the centralized lab while facilitating it, especially in large countries or like, yeah.
Yeah, thank you. And are there any good biomarkers for myelin? Because we heard about the neuroaxonal biomarkers, the GFAP for astrocytes. Anything for myelin?
Honestly, I haven't explored or dived into that part during my work, so I wouldn't, yeah, claim that yeah. Now that my defense has ended, I sincerely thank the opponents for the attention they have devoted to my thesis, and I now look forward to the decision of the doctorate committee, which will decide whether the degree of Doctor of Philosophy will be granted to me.
I hereby adjourn this public meeting of the College of Deans for further deliberations. Deze kant. Please be seated again. Yeah. I reopen the public meeting. By its duly accorded authority, the doctorate committee grants the degree of Doctor of Philosophy to Sherif Sami Ali Bayoumy. I invite the supervisor and co-supervisors to place their signature on the degree certificate as witness of this deed. And while this happened, I declare in public that in the privacy of the closed meeting, the candidate, by a signature, stated adherence to the conditions laid down in the provisions in Article 5 of the doctorate regulations of this university regarding the rights and responsibilities in society and science. Professor Teunissen, appointed by the College of Deans as supervisor, will now perform the investiture. During the pronouncement of the investiture formula, only the doctorate committee stands.
By the virtue of the authority vested in me by the management regulations of the Vrije Universiteit Amsterdam and as supervisor appointed thereto by the College of Deans, I hereby confer on you, Sherif Sami Ali Bayoumy, the degree of doctor, together with all rights, privileges, and responsibilities thereto are pertaining. In witness thereof, the seal of the university and the signatures of the rector and the supervisors have been affixed to the diploma you are about to receive.
Dear Dr. Bayoumy, congratulations with this honorable title. Very proud to stand here today with you. So very well deserved after all the hard work that you put into it. And also congratulate your beautiful wife, Marianne, your kids, family, friends. A lot of them are joining you online today to celebrate this major milestone. So let's go back to the start of your PhD, your application. I was not part of that, but obviously you did well because you're standing here today. And at that time you were living in Finland, Turku, with your wife and then still a very little baby, Laila. And you already had a publication on your name and you worked super independent, so we thought that's a good catch for us. And you could actually have pursued your PhD over there in Finland, but still you decided to apply for the MIRIADE PhD position in Amsterdam and ready to start a new life abroad again. Which was, I think, a very brave move because it was the middle of the corona pandemic. So quite challenging because, how to handle a new country if everyone has the doors closed. But you managed, here you are, you built up a nice social network, you bought a house, your kids became fluent in Dutch, I think you as well, right? And you are... And obviously you received your PhD today, your title. So today you presented and defended your work of the past 5 years, looking at your table of contents. It's a very ambitious thesis. So you covered a lot of topics, techniques, methods, and I think there was a period that you were drowning a bit, but you turned it around. We found out together, I think, what really drives you, what is your joy and your passion, and those are definitely the technical parts of your thesis. And that's also what you showcased today a lot, I think. But I did want to highlight one of your clinical examples also, because that's really worth mentioning, a very impactful outcome. And that's, of course, your clinical review on SMA, which even led to this positive EMA review. So very impactful outcome also. Being part of MIRIADE, of a training network full of fellow PhD students, I think that really suits you very well. because your honest enthusiasm and interest in people really characterizes you. You were so happy when you got together with all of them, which was actually quite special because it was the middle of the corona pandemic and you were quite restricted by all the travels. But the face-to-face meetings, I think, were really a highlight for you during your journey. But also we in the lab enjoy your warm personality and your keen interest in people. So you are always the one asking how everyone is doing, the family, the pets, everything. And not just for asking, but because you really want to know. And I think that's really worth mentioning here. And we actually also invited you to job interviews. I know if you remember, but just because we could really trust your how your intuition for the applicants. And I guess what many of us also remember is that when you came home from a holiday in Egypt, you just had a bag full of gifts for every one of us. You made me a nice cup as well that I drink my coffee from every day. So very kind. And with MIRIADE also came an exchange to ADX Neurosciences. So the presence of Eugene today is a proof of that. And the timing was not great because Sena decided to join your family around that time. But you went, you started your work in Belgium. Then you took a paternity leave so that Sena could be born in Egypt, surrounded by your beloved ones. And then you went back to Ghent to finish it. And then you took a lot of data and prototype essays back to Amsterdam to finish them and publish. Well managed. Not everyone would be able to do that with a young family. And during all of it, I think you also really and truly enjoyed being part of ADX and being part of the business sides. And maybe at one day, a point in your career, you can really put that to use when you decide to make your dreams come true and maybe start a business one day. Which brings me to your passion, ambition, and the last thing that I want to highlight here today. So you want to do science so that you can help people in developing countries with diagnostics where maybe electricity and water and engineers are not that reliable as here in the Netherlands. So you took up this plan, you pitched it to Charlotte, and you convinced her actually to purchase new machines in our lab, the lateral flow equipment. So I think we can consider this lateral flow also as your third baby. Because you like to keep it close, take good care of it, make sure that it behaves well. And I think your oral CSF presentation was really a reflection of that and also a crown on your work. You did very well there and was very well received also, the type of research that you started in Amsterdam. And now with your current postdoc in Leiden, you're continuing that trajectory, and I'm happy that we can still continue to collaborate on that together. So I'm proud to stand here today to celebrate your success. I also speak on behalf of Charlotte, and I'm sure that diagnostics in developing countries will be improved with the inventions that you will bring to the field.
To the congratulations of your supervisor, I gladly add the congratulations of the College of Deans of the university. This PhD ceremony is now completed. Doctor of Philosophy Bayoumy will now leave the room, will lead the procession out of this hall, and I invite you to follow. The reception is in this building, so please follow the committee. Then I ask you all to stand now. I close this public meeting of the College of Deans by desiring that our scientific search for truth and wisdom may be beneficial to the world and to humanity. كل الدنيا بيتحدى اليوم حلوة